Hello everybody, I wanted to make a very quick video here tonight. It is currently 11:22 and I should probably be going to bed at some point, but I'm in a little bit of a math fix and I would like to make a math video before I go to bed because why wouldn't I? Why would I do anything else other than do math? Um, I'm making fun of myself, but I do love math and I do love making these videos. So here I am. Today we're going to be talking about the derivatives of some of the more obscure functions, such as functions in the form of y equals g of x to the x, and y equals x to the g of x. And why are we talking about the derivatives of these kind of functions? Well, because I'm bored and these are kind of functions that do exist, so it might be useful to find the derivatives of these kind of functions. And I'll give an example of the two kinds of functions. For the first one, an example of this kind of function would be x squared plus x plus 1 to the x. You're taking g of x and raising it to the x power. An example of this kind of function would kind of be the opposite. You take x and you raise it to the g of x to the power. Right. And how are we going to find the derivative of these kind of functions? Well, we can find the derivative of these kind of functions using implicit differentiation, using a similar process for finding the derivative of ln x. If you remember, when we found the derivative of the natural log of x, we said we wrote the equation that y equals ln x, right, which is the equation we were looking for. And then we raised both sides, or we did e to the power of both sides. So we're going to end up getting e to the y equals e to the ln x. All right, and because we've done the same thing to each side, we put e and raised it to whatever's on either side. Because we've done the same thing to each side, this is a legitimate thing to do to an equation. So we're going to get e to the y equals e to the ln x, and we know e to the ln x is just x, so e to the y equals x. Then we implicitly differentiate each side. So we applied the derivative operator with respect to x to each side. I'm not going to write it here, but we're applying the derivative operator to x as well. And the chain rule tells us that on the left side, we're going to get e to the y times dy dx equals 1, the derivative of x. You divide both sides by e to the y, but e to the y equals x. From this equation right here, we said e to the y equals x. So instead of writing 1 over e to the y, I'm going to say 1 over x. And that's the derivative of ln x using implicit differentiation. And we're going to do a similar process to find the derivative of our functions we just listed. So for the first one, we have y equals g of x to the x. We'll start with this one. I don't know if that was I forget if that was the first one I wrote down, but it doesn't matter. All right, so a similar process. We're going to take the natural logarithm of both sides. And we're going to get that the natural log of y equals the natural log of g of x to the x. And the power, is it the power rule for logs, I think that's what it's called, tells us that we can take the exponent here and bring it to the front. So this ends up being ln y equals x ln g of x. All right, so now what we're going to do is we're going to differentiate both sides. So we have ln y equals x ln g of x. All right, so we're going to differentiate both sides. So on the with respect to x, we're going to take the derivative of this side and differentiate this side. All right, so the chain rule tells us the left side will be 1 over y times dy over dx. And then this side, from the product rule, is going to be x times the derivative of this, which is going to be 1 over g of x times g prime of x. And the product rule then tells us we have to take the derivative of the first function, which is just 1, and times the second function, which is going to be ln of g of x. Sorry about that. All right, so I can simplify this a little bit. We're going to get 1 over y times dy over dx equals x g prime of x over g of x. And we can find a common denominator here. We can say that we're going to take plus ln g of x times g of x over g of x, because when we take the second part of the sum in the top here and divide it by g of x, we get our original term. So we're just finding a common denominator, adding it to the top. So then we're going to multiply both sides by y here, because then it'll give us dy dx on our own. But remember, we said that y is equal to what was the original one we did? It was g to the x to the g of x to the x. So y equals g of x to the x. All right. So when I multiply both sides by y, instead of writing y on the other side, I'm just going to write g of x to the x. All right. So then the derivative with respect to y, or the derivative of the derivative with respect to x of g to the x. Sorry, I'm having a big major brain fart moment. You can see the time below it is pretty late. But the derivative of this function, because we isolated dy dx, is going to be g of x to the x, because that's our y value, times what we had before, which, okay, that's great. Don't worry, we'll get back there, and we'll get back in just a second. Come on. All right, g of x to the x times, I believe it was xg prime of x plus ln g of x times g of x over g of x. All right, so that's the derivative of our first function using implicit differentiation. All right, now let's go to the second kind of function. And we're going to do the same principle, so I don't really have to write, I can kind of explain it a little less because it's the same principle. But we're going to get y equals x to the g of x, all right? So then using the same process before, we're going to get ln y equals, you take the ln of this, you're going to take, if you take the ln of this, you're going to take the exponent and bring it down to the front, so g of x times ln x. All right, so you differentiate both sides with respect to x, you get 1 over y times dy over dx equals, and the product rule tells us this is going to be g prime of x times ln x plus g of x over x, because it's the same thing as saying g of x times 1 over x. All right, so y equals, I'm not going to simplify this case. Y equals x to the g of x. So I'm going to multiply both sides by y, but instead of writing y, I'm going to write x to the g of x. So we get dy over dx equals x to the g of x times g prime of x ln x plus g of x over x. That should be the answer. Yep. All right, so that is the derivative of a function in the form of x to the g of x. So to summarize, I will not summarize because I don't want to go back to the thing and rewrite the equations. You can just go back to the original part of the video and see the equation there. But that's the derivative of x to the g of x. We found we used implicit differentiation to figure out dy over dx, and it gave us this equation. All right, so I don't know how that's going to be useful, and we found the derivative of g of x to the x using implicit differentiation as well. I don't know how it's going to be useful, but now you can say that you can find the derivative of these kind of functions, and I think it's pretty cool that you can derive derivative functions on your own, just knowing the rules of implicit differentiation. So that is today's video. I hope you enjoyed it, and I'll see you guys in another video.